In this video, I wanted to explore a concept called specific heat capacity. So to do that, I'm here in my kitchen and I've put a plastic lid over here on the stove. You can see right there. And this is a skillet. In this little cup here, I have some ice cubes. And lay the ice cubes out so I can find a couple that are kind of similar size. I'm going to put the two cubes, one on the pan and the other in the skillet. And I'd like you just to observe over the next few minutes what happens. Of course, these would be at the skillet and the plastic lid would be at the same temperature because they've been sitting here next to each other for quite some time. But are you noticing that the ice cube that's in the skillet is beginning to melt, but the ice cube that's sitting on the piece of plastic is not melting? Now I'll let it run for another minute or so and see what happens over the next minute. Now this skillet was not hot, it was just sitting on the counter. The plastic lid was actually sitting in the skillet. So why is the ice melting in the skillet but not in the plastic pan? Well, you may be saying, wait, you probably have the fire on underneath there, but there's no fire. So the burner's not on, yet the ice is melting. We're in the same room, sitting right next to each other. This one is actually closer to the burner that I just had on a few minutes ago when I was making a phase change demonstration. So it's a little warmer over here on the left side than it is on the right side, but yet the ice is melting in the skillet. So why is that? Well, it has to do with the way the two materials transfer heat. You all know that metals transfer heat more effectively than plastics do, or glass for that matter. If you look at my spoon rest over here, you can see those are not really melting either. So the rate at which something transfers heat we could think of as something called the specific heat capacity, or the heat capacity. Metals have a low heat capacity. Plastics, glasses, they have a high heat capacity. And what heat capacity has to do with is the amount of energy that it takes to raise the temperature by a certain amount. So when we talk about specific heat capacity in this unit, we're talking about the amount of energy that it takes to raise 1 gram of something by 1 degree. So you see, it doesn't take much energy to raise the temperature of metal by a degree. It takes quite a lot of energy to raise the temperature of plastic by 1 degree. So metals have a lower heat capacity. That means that they're going to be able to transfer heat faster. Heat goes in fast and it comes out fast. In this case, heat is being transferred from the room through the metal to the ice cube, and that transfers energy into the ice cube, which causes it to melt. The plastic doesn't transfer heat from the room anywhere near as effectively as the metal does. So the ice cube just sits there and it will gradually melt, but it'll take longer because it has to get its energy from the air molecules around it. In the skillet, the energy is being transferred through the actual metal material into the ice. So you get the same air interaction that we're having over on this one, but you also get a lot of energy transferred into the bottom of the ice cube through the metal. So that's a little introduction to what I'm talking about when I talk about specific heat capacity. It's the amount of energy that it takes to raise the temperature of something by 1 degree, which translates into the practical side of that is that things with lower heat capacity transfer energy more effectively. You can see this one's starting to melt, but there's still not really a puddle of water down there, whereas this one is almost completely gone. And that was in a 5-minute time frame.